Thank you. So everyone who was here in this room last hour heard one of the panelists say that his favorite use for AI up to this point was in planning a vacation for himself. Now, AI is moving really quickly because there's a published article in Technology in Asia back in June of this year where someone tried to do that same thing, and none of the kind of more traditional AI platforms could deal with the problem because of CAPTCHA images. Everything the agents were trying to scrape on the internet were being caught by CAPTCHA, and so the system was not able to bring in the information. So this is kind of a way of saying it's really important to keep up with how things are changing on a daily basis in AI and what's becoming possible now that wasn't even possible a few months ago. I'd like to start by asking our panelists, who are each working on a kind of different leading edge part of AI, how they are, what they're doing and how it's impacting AI. So let me start with Dr. Asai. Let me ask you, what kind of work are you doing in AI right now and why is it important?
Okay, yeah. Hi, everyone. Nice to meet you. I'm Akali, and I'm a research scientist at an Institute for AI right now. And my research is trying to tackle a central gap between like traditional parametric language models and also like new type of language model, which I call augmented language model. Specifically, like my work has been focusing on retrieval augmented language model or like retrieval augmented generation RAG. And the core idea is that if we use normal traditional parametric language models, those models have many limitations. For example, they can hallucinate so frequently. The knowledge can get outdated because they are trained on much older large-scale pre-training data, or like they don't provide any attribution to what they generate. And I've been working on the area of retrieval augmented language models where like we combine language model with external data store and like we retrieve knowledge from those data store, incorporate them at the inference time so that language model can reduce hallucination or can provide more up-to-date information. And most recently, I've been trying to see how those retrieval augmented language models can be trained at much larger scale, perform much more complex tasks, for example, building deep research agent, and also like beyond just like search or retrieval augmentation, how those systems can generalize to completely new tools or like
So
or like
Akari-san, can I ask a follow-up question? Will your work make the language models larger or smaller or interact in a different way?
actually, like I want to make language models smarter by giving them ability to use external knowledge or like tools. And we have seen that with those retrieval augmented language models, we can even make language models much more powerful by using much smaller language models. Um, but I'm also like happy to discuss like whether like we should keep increasing the size of language models or like no today.
Okay, great. Next, I'd like to ask Sakya because Edge Cortex is really working on AI processing at the edge and micro data centers and so forth. Tell us a little bit about it.
Sure. I think we are really at an inflection point today. I've spent the last 2 decades of my career in AI industry well before deep learning existed as it exists today. But if you look at 2023 in a manner, just 2 years ago, the conversations was really about conversational AI. Gen AI, so to speak, was all about text and kind of responding to our requests in a manner that's more reactive intelligence. What we are seeing today, I would say 2025 is really the year of agentic AI, and that's how do you get real outcome out of your AI, make it act in the real world, and that's really where we come in. So our focus really is if the conversation has shifted from reacting to our requests, answering our questions, to a lot more about acting on our behalf, delegating tasks to the AI agent, making it autonomous in a manner. How do you actually implement that in the physical world where you need efficiency, where you need compute scalability? And in order for it to actually realize that, let's say on a robotics platform, it needs to operate under constraints of size, weight, power. And that's kind of center point in our focus area, and we are looking at, in a manner, how do we build agentic silicon, semiconductors from the perspective of agency, enabling that autonomy future. It's not immediately now today, but that's the world that we are getting towards, the shift that's happening as we speak from conversations towards actions.
So it's an important shift. Do you think that people as users of AI need to change the way that they interact with the AI?
In a manner, yes. So I think even in our daily lives, I think all of us are using tools like ChatGPT. It used to be tools, and I'm using that word very deliberately. And now when we are steadily moving towards those agents having feedback loops, having persistent memory, if that tool is able to look back in the history of conversations that we have had with that tool and is able to tap into that information to give me actionable intelligence that I may not have had before, it's really acting like, I'm using that word cautiously, but as a human partner, so to speak, would do. And I think we got to be able to recognize that, and also, very importantly, build guardrails in terms of how do we verify that information that comes back and what information we provide. So, in the last session, there was a very clear conversation around the importance of data. Yeah. A lot of the data that we have as a company, as well as many of the other companies out there, is fragmented, it's unstructured. And so we got to be able to take that data and make that ready in a manner that it provides actionable insights for an agentic AI.
That's a really good point that we will come back to. Shane, you'll probably have to shoot me if I ask you what you're working on right now. So instead, let me ask you, what do you find is the most exciting new thing in AI this year?
I was going to prepare to answer.
Well, say what you can say.
Sure, yeah. So I work as a tech lead within the Gemini, working the reinforcement learning. So we kind of all talk about the AI agent, but essentially reinforcement learning is kind of how to teach AI to act as an agent. And it's really important. It has like a lot of, so basically like reinforcement learning is different from supervised learning, where basically the AI can do online learning. It can sort of test its hypothesis and then collect real world experience activity and then learn from it. It can basically, for example, teach the AI to really improve its like math coding skill, because math and coding, the computer can give its feedback. It can very quickly learn. It can also, for example, use tools like retrieval, like RAG that Kari mentioned about, or computer, and then act in the real world with a real system, retrieve knowledge or use tools, and then learn how to do it. And then also, like say hallucinations, like why do, for example, like language models hallucinate? It's also like like humans also hallucinate. But what we kind of know is like when you kind of hallucinate certain words, like if you miss like a famous person's name or that, you kind of have real world consequence, like you lose your job or you lose the opportunity. So basically AI is kind of similar. And the only way for kind of AI to be more calibrated, like kind of human, is to really do online learning, reinforcement learning, and learn to know the consequence of your actions. So essentially, I'm like a tech lead on that. In terms of the what's most exciting, it's pretty much extension of AI agents and the reinforcement learning in that we basically kind of see the AI is growing in two axes. One is autonomy. Autonomy is basically, how many minutes can the AI act before the human had to intervene? So essentially, like it's kind of like self-driving. How many miles can it drive before the human had to intervene? That's been getting very long. Recently, like one of the Frontier Lab, they published a coding agent can code for 30 hours, and this was much shorter, like a year ago. Another axis is grounding, which is like how much of the world can it understand and act in. Previously, the AI mostly understand the text space, like chat, but then right now, through kind of video models, through the multimodal language models, it can really understand like space, time, this like 3D world, and by increasing real timeness, it can really like hopefully like be much more included in every aspect of like a human life and work. So basically, within those two axes, AI agent is gonna have so much room to grow, and we're very excited to make that happen. Yeah.
And I guess that the reason that that's exciting is because you can do more with them, right? You can ask them to solve more complex problems. You can let the agent work autonomously. Like you said, it drives by itself for a lot longer, correct?
Yeah, like I don't want to like, for example, I need to sleep every day.
Yeah.
But then if I actually can make the AI be acting in more part of my world, and then also act longer, more autonomously, then I can basically make the, bunch of, AIs kind of do the work for me. Yeah.
So I think hallucinations are an important enough topic that we should really kind of go through the panel and see. I'm guessing that hallucinations will always be a part of an AI creating new content. So Shane, let me start with you. How should people deal with hallucinations?
Yeah. So when people talk about kind of hallucination like OM and that, I actually kind of mentioned like, so my daughter is 3-year-old, and then when she does some like reasoning these days, but I would say like 90% of her reasoning is like hallucination. She just like it doesn't follow causality. So in general, like a lot of reasoning and that just kind of by nature have hallucination. And then, but the reason we're so kind of good at it is that we basically kind of learn the consequence of some hallucinations. For example, if you get some of the reasoning of physics wrong, then we don't get good grades at school, so we cannot get a good job. If you get some hallucination of, like for example, like while driving the car, then we could lose our life. And if you get some hallucination of, say, like it at work, or some like important part of the work document, for example, in the medical sort of terminology, if you get certain things really wrong, then you have consequence, you lose your job. So in a way, one way kind of for me to understand is like AI basically hasn't lived among us and hasn't really like experienced the consequence of, for example, if you get these tokens wrong, what are the real consequence? But humans, we know. So in a way for us, when we do learning, we know better kind of credit assignments and we know like which part. So I think that's kind of sort of like one of the big gap between the AI and kind of human, and there also some kind of like research to hopefully kind of bridge that. Yeah.
Okay,
And
Sakya, yeah, you're
I'll,
next.
Yeah, I mean, if I may add to that, so I would disagree a little bit with you, Richard, on that
Okay.
point that hallucinations are here to stay. I think it's a byproduct of the models that we're using today. It may or may not continue to exist as AI scales up. I would wager that there's going to be better models. Just taking a step back on what Shane was also mentioning, I think today we don't really have fully autonomous systems the way we describe agentic AI. I think that's forthcoming. That's also one reason why self-driving cars in that sense hasn't been realized in that scale in which we would have wanted it to be realized at least 10 years ago. What I'm getting at is, if you look back at where the conversation started, I think there are two ways in which AI is being used today. One is as an end customer, as a personal, as a user, it's a lot more about personalization. And there is going to be a sense of autonomy there. For example, I think in the previous session, there was a point made about, when you're booking your next trip, you can actually train an agent quite quickly to do that mundane task for you, just figuring out what your travel itinerary needs to be, and potentially, attach a set of data behind that agent that can go ahead and book those tickets for you. On the corporate side, it's a lot more about operational efficiency. The area that we see AI agents being used, for example, in an autonomous manner, or at least a semi-autonomous manner, is for triaging customer requests, or essentially tickets. So as a service tickets comes in, there's a lot of mundane repeated tasks that needs to happen, and you can automate a lot of that process. However, I think the area that remains to be challenging is, going back to your point of hallucinations, I think the first point is today's models continue to have those kind of hallucinations or essentially errors that they occasionally make. And in order to deal with that, I think the answer is not to go completely with autonomy immediately, but to balance it out, probably with 80% of AI control and 20% of human in the loop. And I think we have seen that even with models like ChatGPT, where you have this feedback mechanism that is provided to answers or responses provided by the AI agent to essentially course correct. In reinforcement learning, as Shane mentioned, I come from that background myself, it's about providing rewards or punishments, so to speak, where those rewards or punishments over time enable that AI agent to learn from the mistakes that are making. And I think we'll see a lot more of those happening in the near future to deal with today's problems of hallucinations.
So Akari-san, I think the two panelists have set you up. Do you think that we will be able to eliminate hallucinations? And until we do, how can you recognize that it's hallucinating? The interfaces are so natural and so good.
Yeah, I think it's a pretty interesting discussion. And my argument is hallucination can be reduced, and it has been reduced significantly because one, by having more like larger and like longer trained models, those models memorize much more knowledge and like they hallucinate much less compared to like GPT-3, for example. Another thing is that techniques like retrieval augmented generation has shown to be quite effective to reduce hallucination. Like it could reduce hallucination from like 90% to 10%. So there's some hope. But at the same time, we still have seen like maybe 10 to 20% of hallucination. And my take is like at least like maybe like in the next like or next year span, we will still have the issue of hallucination. And the important thing is that how we should design like interface or like how we should design mechanism so the human can intervene. So one way is that we can build attribution, kind of like verifiable interface where like human can take a look at the model response and make judgment on whether this generation is fully reliable or not. Another thing is that models should be more um, like better at saying like I don't know or like expressing uncertainty. And even the state of that model can generate factually incorrect statement with high confidence. And this area is has been studied, but still like we don't have really like clear solutions. And I think it's exciting area for research and like product.
Okay, thank you. Um, So my next question is another problem with AI is it's rather expensive. I'm seeing that for an enterprise to use ChatGPT, they may be spending upwards of $50,000 or $60,000 a month. And so, Shane, how do you see that working out? How do you see AI becoming more cost effective?
Well, you use Gemini,
Okay.
which I think is generally cheaper. The price, yeah, the performance per cost is pretty good.
What do you think is the cause of the high cost? Just their business model, or do you think that there is a fundamental technology issue?
Well, one is that like a lot of Google models are kind of built on the TPUs. TPUs are kind of manufactured by Google. And then one thing is that you don't need to be like influenced by the external demand. So GPU has like a lot of demand externally, like different companies kind of bid in to kind of buy different GPUs. So that cost naturally kind of fall to the user. Um, well, like Google's TPUs basically kind of Google controls pretty much like almost kind of all the supply, at least
Okay.
for development. And then the
Akari-san,
another thing is
yeah,
that uh, another thing is basically the it can do like end-to-end optimization, but I can also can answer more like a non-company kind of way
sure.
as well.
Okay, so Akari-san, let me ask also you, how do you see the cost performance of AI developing?
So I personally super excited about like open language models. Hopefully like Shane will not like kick me out from this session. But like I think this year particularly we have seen a huge success of open language model, like open weight language model, like Qwen and DeepSeek. And like some of those models are getting like much smaller. Also like the capability is not as good as like GPT-5 or like Gemini based model. But I'm kind of hopeful that like we will have much better like open models which people can host in their like own machines or like even like on their own laptop. But the key of those models is that those models must be really good at using like external modules like tools because they cannot memorize as much knowledge as like other huge 1 trillion parameter models can do. But I think this year, especially like there's a lot of like new research and even like product around those like open models or like open infrastructure. And I was I'm hopeful that like we can fill the gap between like the best of the best like Google open AI models and like open language models. But we'll see. Like I'm really
Okay,
curious like
so
what
I have
Shane
to
is.
get into geopolitics here a bit because the Chinese models are almost all open. And do you think that's an advantage for them over the American situation now? Akari-san, that's for you.
Um, I think one thing I need to clarify is like all of the most of the state of the Chinese models are open weight but not open source. So like they release their weight, but they don't release the detail of their training. So that actually like makes it a little bit difficult to fully understand what those Chinese models are actually doing. Um, and there are some research institute that try to have like more fully open source language model. Like AI2 is actually like one of those companies. And this will help us to like more understand like how we can build more powerful model. And like each different like companies or like a research institute can like build their own like customized model using those insight from those open source models. But I think still it's amazing that like those like DeepSeek, Alibaba release open weight language models because more and more companies now like don't release open weight models or like being more strict about what we can publish. But I'm also like curious what other panelists think about this thing.
Go ahead, Sakya.
Yeah, if I may add to that, I think your original question regarding the unit economics is very, very important. So where we come from, of course, for us, we're looking to build silicon that is a lot more efficient. But the reason we are doing that is, I think if you look at this exponential growth of AI, whether that's generative AI or agentic AI, I don't think the solution is going to be shifting a cloud vendor from A to B. It's really fundamentally rethinking. If you're going to deploy an agentic AI system in the physical world, it has to work along the constraints that are dictated by, that physical world dictates. If you just step back and look at the growth of generative AI, that's a conversational agent. You're asking questions, answering back. The moment you get into agentic AI, there are feedback loops, and that means there's a multi-step process that's happening repeatedly. So the unit economics actually just blows out. The amount of energy and amount of essentially electricity that you need, the computing power that you need for an agentic AI at scale is a lot greater than what we have seen with generative AI.
Which a lot of people are using to predict that companies are going to cancel a lot of their AI agent projects. Gartner is saying cancel 40% of them by 2027. Because I'm already understanding that when you're asking an AI agent to write code, it gets out of hand. It's costing the companies more than it costs to have their people write code.
Yeah, and I think there is a fair amount of speculation in the market. I think the answer is not to completely shut down and not kind of do those things, but really run pilot projects, run use cases that are can be implemented with measurable outcomes in near term, and just stepping back, not everything has to be on the cloud. You got to invest in efficient infrastructure, and in a manner, I would say the conversation is shifting from autonomy to what I would call sustainable autonomy. How do you really deploy that in the real world and distribute those agents across many different platforms? So for example, we talk a lot about edge. You have the cloud infrastructure that has grown because of the data center and the growth in generative AI. Equivalently, if you're now trying to deploy these on robotic systems, that's an edge. That's typically further away from the cloud. And you need to invest in those kind of efficient compute systems and infrastructure that can run those agentic AI systems in a distributed manner rather than being completely centralized in the age-old paradigm.
So I do have go ahead, Shane.
Sorry.
Yours.
Yeah.
Go ahead.
So one really kind of important thing for the company, for the AI agent, is really to ensure that you have a full control of the agentic pipeline and the evaluation stuff at your company. If you're just kind of making like a product, then maybe kind of user kind of just want the fully autonomous thing. But if you're like doing kind of business and then making the thing, what you kind of want is that you kind of want to really kind of write your own kind of agentic stuff, and then make sure for every call that you kind of make to LLM, you track how that will behave for different models. So some could be just kind of small models, open source, like open weight. Some could be like small model or large model from the sort of like API providers. But what I kind of really recommend is that you have a full control of the agentic framework and then do really thorough evaluation of that. Because I really agree, if you're just going to run the most expensive model for all the process, it's going to be very costly. But what you kind of find is that you can, by kind of doing very careful analysis, one is like you can actually kind of better, like design better and better agentic pipeline just by doing the exercise. But the other is that you'll kind of find many components of the calls can be really sort of isolated. That you kind of know it's actually really valuable to small model, or if it's not, if you know, for example, some literature on what kind of tasks can you really tune to do well, like RAG, or just like even to reduce some kind of hallucination for like narrow domain, how much compute, what kind of stuff is needed, what size of model is needed, then you can actually take the open source, open weight model, and then do something with it. So basically recommendations, take a full control of your agentic pipeline, the code, the evaluation, and then all the pretty much like traffic that come from it, and
Now, when you
repeatedly kind of
say
analyze.
full
But
control,
my belief is like, yeah.
when you say full control, are you talking about by the user or are you talking about by,
No, developer, like a company developing it for
okay,
the
okay.
internal use or making to a product.
Yeah, because
Yeah.
I do want to
And
ask
then
about,
I think what I can guarantee is that you can always make a system where of different kind of model components such that its costs will be lower than the economic gain can get out of it.
okay, I do want to ask about human in the loop. Satya, you had mentioned a few minutes ago that 20% maybe can be human in the loop and it can be more autonomous and go for longer periods of autonomy. Akari-san, what do you think about the kind of best practice now in designing a system? How should the people fit in? How should the users be using Agentic AI?
I think for me, pretty important point is AI so should be able to express like when their answer is likely to be incorrect or like it's not sufficient so that they need human interventions. And because when we say like, oh, like maybe AI is correct for like 80% of time, but it will be wrong in 20% time, the challenge is that usually like we don't know exactly like where the model is failing or not. So I think it might be also related to the Shane's point, like we needed to have like code control and we needed to like do evaluation and we needed to understand like where those model be successful, like where those models are likely to fail. And I think the first step is like understand where those models can fail. And or it could be like developers understanding their limitation, or like those models can express uncertainty or like their potential limitation. And after that, like we basically make the human users to be more involved instead of like just blindly trust AI responses.
Okay,
And
Satya?
one thing to kind of add on the Akari stuff is that when I talk about the agentic workflow, humans are part of the agentic workflow. Humans are pretty much, for example, the AI will learn to do a function calling. You will call a human. For this part, I need to probably check with the human. And then so human is kind of part of optimizing the agentic workflow. And you should also kind of evaluate humans as well. For example, for this part of the workflow, you can just kind of hire like an intern to kind of look at it. Or for this part, you kind of need like AI expert to sort of judge how to improve it. For this part, you kind of need like a domain specialist to look at it. And how much percent you should take a look to ensure this agentic pipeline has reliability of say over 90, 99%.
Okay, Satya?
Yeah, in fact, I was just going to add to the point that Shane just made. Rather than treating the agentic AI as a tool, I think we need to start treating that as another member of the team. And that also means that naturally, the typical KPIs, guardrails, auditing mechanisms that we have for people that we hire, you got to have the same mechanisms for an agentic AI as part of your extension of the team. In a manner, you got to think about agentic AI from the perspective of what are the typical parameters that we are defining within which it works, and whether that agentic AI is fulfilling those parameters or not. In our company, something that we look at is red team and blue team mechanisms for agentic AI. You can actually implement similar systems where you have both humans acting as part of, let's say, a blue team, and AI agents acting as part of red team. And in the near future, you might just have that in terms of red team and A team being done by agents itself. That is the natural feedback mechanism, again, comes from this whole idea of reinforcement learning, where you have interactions and essentially feedbacks across what that agent was built to do and whether it's fulfilling those requirements in the first place or not, and then correction mechanisms. And those feedback loops is what differentiates agentic AI from typical generative AI.
Okay, thank you. I've got one more round for the panelists, and then we'll open things up to audience Q&A. I want to ask about the place of Japan in the current situation with leading edge AI. What's necessary and what does Japan already have? This, the theme of the whole conference is Pax Japonica, right? So, Shane, what's your sense of where Japan is in regard to leading edge AI research?
Sure. Yeah. So I've been in the kind of field of deep learning for more than 10 years. I work in multiple countries and then mentor like a lot of students from different places. I was also like a business associate prof at U Tokyo. Objectively speaking, I think pretty much the community in Japan is kind of behind than other other countries, not just like Europe, like America, like Canada, but also like more like nearby kind of Asian countries. And
So
one of the
is
kind
this
of
just
reason is
because they're
that,
starting from further back? Is there
well,
something in the
there are
Japanese system?
many reasons. For example, 10 years ago, like one of the lead professor at AI, he basically had control for the budget for like 7 years, but then he was like against the deep learning. So he kind of focused more on the statistical machine learning, so that kind of definitely delayed. And then overall in Japan, basically, there's not much sort of like idea of, like a student of the professor exceeding the professor. So in the US, that's like very common for like a student to kind of become much more famous than professor, like even very quickly after graduation.
Yeah.
But in Japan, we don't really kind of see that. And then, Japan has been pretty much kind of shut down in terms of English education. And they kind of devalued the IT education. Like there wasn't like high paying IT job until very recently. So all those kind of factors kind of accumulate and then basically kind of made it sort of kind of behind on it. The good part is that so like a classic kind of science, like it's like some like statistical, like mathematics, foundational mathematics. There's still some kind of good people. The like material science, like robotics, hardware side kind of still have kind of good people. So they're kind of people from those, but not because of this kind of like culture and structure, it's kind of hard to catch up with like very rising trend. Yeah,
Okay.
and then I can kind of go on and on, but love to hear from others first.
So let me ask Akari-san to go next because you've just taken on a faculty position at Carnegie Mellon. There are very few Japanese people who are in overseas institutions. We have one professor who is Japanese in computer science at Stanford. But how did you get there, and what would you like to see in order for Japan to have more influence?
Yeah, so for me, I did multiple research internship when I was in undergrad, where like I interacted with researchers from different countries and like different institutions. For instance, my first research internship was with like Recruit Institute of Technology, where like the head of research was a former professor from University of Washington, and he's the one who kind of recommended me to do PhD in US. And then like I also did internship at Microsoft Research Asia. And I think the one challenge for Japanese research community, particularly like in AI right now, is that the Japanese community is kind of like isolated because like not many Japanese students are going to US for PhD, or like not many like uh, communication or like collaboration between like US or like North American institutions and like Japanese institutions. And I personally believe that a lot of the state of the art research is happening in like US, Canada, or like some European institutions. And it's pretty important to have like active collaboration or connection with those communities. But unfortunately, been I've been like helping PhD admission, but there are so few Japanese applicants for PhD. And I think the difference between Japan and other East Asian countries, for example, like China and South Korea, is like there are so many students who are coming from those countries, and then like they do PhD in US or Canada, and then like later they stay in US academia or like US industry, or like go back to their own countries and start their own research group. But this kind of like human flow is not happening actively, and I think this should be improved if Japan wants to like take a lead of like AI research or like AI product.
Okay. On the flip side, Sakya, you have founded your company or growing your company in Japan.
Yeah, I mean, I'm extremely bullish about Japan and the future, and I take a little bit of a different, maybe complementary perspective. So just to give you a background, so I did my PhD at Max Planck in Germany, so a very different world. I moved to Japan with Riken, both the Brain Science Institute as well as working on Fugaku. There is a ton of research that is actively happening in that area, and quite successfully so. I think Fugaku, until very recently, over the last, let's say 5 years ago, used to be in the top, it was the number one in the top 500 greenest hardware in the world. So I think there is a lot that is happening today. And where we see, so in 2019, when I was starting our company, so we are still fairly young, but growing actively, I think almost everybody said not to start the venture in AI and hardware intersection in Japan, resonating in a manner kind of the conversations here. But we nevertheless did it because there was a high bias towards action. And I think that's what Pax Japonica is about, having a high bias towards action, getting it done. And today we are seeing there's a huge support and influx from the government as well. For example, we have been successful in terms of massive subsidies from METI and NEDO. That goes a long way in terms of deep tech startup companies in the order of $50 million or so, which are non-dilutive. And I think those help and enable the overall deep tech industry. If I give you another statistic, from 2018 to 2023, the overall startup ecosystem and investments in Japan has grown by 25% CAGR. That's still short of the rate at which we have seen growth happening in the US and Israel and China, but nevertheless, I think it's actually in the right direction.
Okay. Anything from other two panelists? Go ahead, Shane.
Okay, let me kind of add just kind of one point on kind of both of the. So overall, I think the Japanese students are smart and then kind of hardworking. But I think the critical thing is kind of miss is kind of how big the world they're exposed to from like early day. And I'll actually kind of use an example from Fugaku, supercomputer. I had a chat with a U of Tokyo PhD working on like supercomputer. But when I talked to him, for example, when I mentioned about how when Tesla is designing the new sort of Dojo chip, really optimizing for particular thing about how you train large models. So it's kind of really getting inspiration from like optimizer using large models. So it was really like supercomputer, but designed for deep learning. But when I talk about the student, like, does your team kind of think about deep learning? She's like, no, we only care about supercomputer metrics. So one is like, I feel the Japanese industry have a tendency to stay within their discipline and then don't look around to other labs on that. That's like one. The other is sort of like beyond Japan. So what I kind of see is like Japanese can learn from best Japanese, but all the other people can learn from French Global, like the best Koreans, best Chinese, best Vietnamese. They learn from everywhere in the world. One kind of quick example I can gonna give is that there was a junior professor at Shanghai, and he had 200 students, even though he was a second year being a professor there. 190 of them are from very competitive class, and they're basically undergrads. And those undergrads, every summer, they're gonna do internship in the top US lab. They go to Stanford, they go to MIT, they go to UC Berkeley, and those kind of places, because many of the alumni already are there. And then they basically, by the time they finish undergrad, they already have a top publications, and they have a connection with the top professor at MIT, Stanford to go there. So best students in China, Korea, Vietnam, like, they're not satisfied at staying in the country. They always look beyond to kind of do basically the best research wherever they go. By the way, I did my PhD partially at Max Planck. So essentially, like, you go anywhere in the world where there's the best research. Well, in Japan, I kind of tend to see less of that. So to me, like, one of the critical things is that they're smart, they're hardworking, but their world needs to be much broader. Their action state need to be kind of broadened. So I'm really kind of happy for Akari and then also Sakia to kind of be there and then talk to other and hopefully like inspire like more different things.
Yeah, I mean, I have to add very quickly. So overall, I agree with the comments that Shane made. But I would also say, like, comparing, I'm just narrowing it down, but comparing Fugaku, let's say Tesla, would be an unfair comparison. One is a research lab, and the other is essentially a company, a startup. And today we are seeing that shift happening. So I do agree that a lot of the work historically has been deep learning shy, and that's the reason, although historically, if you go back and look at Sunichi Amari, maybe he hasn't been recognized enough in terms of his contributions towards deep learning, but it has existed from the very beginning. He is, of course, a Rican professor. We as a company, the whole reason we are doing what we are doing is that you are seeing this dramatic shift happen of recognizing that you got to be able to build companies and do work in the AI hardware space, semiconductor space, cutting edge deep learning space, which may not always be possible from a research institute, and you got to build a company around it. And I think that's what Tesla really is. And today you're seeing a shift in that direction. Just to give you another statistic, not to kind of brag here, but again, we as a company, we are the first company globally to be a semiconductor company working with the US Defense Innovation Unit. So you're seeing this shift happen that even when companies that are younger, they have the ability to work alongside the US in critical areas where AI, defense, national security, dual-use technologies, and even space come all together. And I think those are the key reasons why overall very bullish about Pax Japonica.
Excellent. So, Akari-san, in the spirit of G1, instead of saying just, things that need to be improved, do you have suggestions for how we can get more students to apply to spend some time overseas? I mean, not to make Japan have a brain drain, but really, how can we get young people involved in the worldwide AI community?
Yeah, that's pretty good question. That's what I've been trying to in the past few years. But I think that I still, when I was applying for PhD, I was figure like only one student in my year in like University of Tokyo, like engineering, who is applying for US PhD directly. But these days, like I have seen like more and more students like sending emails to me and say like, oh, I'm interested in like applying for US PhD, and I wanted to like get some like feedback or I want to get some advice. So I think it's the number is slowly increasing. And one uh, reason is that like the past like PhD student, like Japanese PhD student in like US institutions have been trying to like encourage people to like apply for USC PhD or like PhD like beyond Japanese universities from like different like panels, like invited talks or like blogs. And those things, those small things have been like affecting positively, and I think it's a good thing. But to make it even like bigger, like to make the impact bigger, I think also there should be like more systematic effort to like, for example, like encourage Japanese students to do like intensive at like US institution, as like Sam mentioned, or like having like more like bigger research institute where like Japanese students can interact with like researchers from different worlds. For example, like Microsoft Research Asia is pretty successful case in that ways. Like there's so many like students from like Beijing, Peking University or like Tsinghua who did internship there and then like went to US for PhD and then like now like becoming the core like AI leaders there. So those things could be like both like micro level and like macro level effort could be quite helpful.
Okay, excellent. So let's open the floor to questions. 30 seconds for your question and direct it to one of the panelists, please. Can we get a mic?
With the increase in autonomous AI and how AI can go long periods without human intervention, I'm just wondering how ready society is for this technological change and how we're going to be able to adapt. This implies this has incredible implications on the way in which we work, the way in which we see work. So I'm wondering, what the implications are there. And if we're
So social implications of these kinds of development of agentic AI. Shane, what do you see on that?
Yeah, so usually I like the kind of word like Jeff Hinton was kind of saying. So he was kind of saying something like any technology that can fundamentally improve the productivity of, people have the potential to improve society. But, whether or not it's kind of up to the humans. So to me, if you purely rely on capitalism, then it could lead to very kind of bad winner take all. But I think this is kind of where, probably more like politicians and different countries with different values can really kind of step in. And I'm also kind of hoping Japan can kind of be part of it, because in Japan, like there's kind of more sort of kind of idea of like mixing the sort of, morale with kind of capitalism come together. So I kind of do hope we can kind of go beyond the purist kind of home capitalism and then talk more beyond it, how we can
Okay.
provide society based on value added.
Okay, that's great. Let's take two questions. So you first, you second.
Yeah. So in when it comes to AI hardware startups, I think it's more challenging than AI software, right? So and generally, like Japan, it has a good image for hardware and electronics. So I think what are the challenges when you set up the AI hardware startup? Did you leverage any existing big players which were traditional players in hardwares and electronics, or did you do everything from scratch? So and how challenging is it for any new startup to?
Excellent. That one's obviously for Sakya. Before you answer, though, Yano-san, let's get your question.
Thank you. My question is on creativity. Current LLM and GenAI is based on pre-trained data and information and limited capability of creating new things. What do you think about the future prospects on that possibility?
Okay, great. So Sakya, you take the first question.
Sure. Yeah, so of course, we are an AI hardware startup, but I think the secret really is not to start with hardware. And that really goes back to the whole conversation around AI today. We started with the focus on software. The reality is, and in this kind of dovetails into the first question as well, when we bring AI into the world, it's going to have a societal impact. It's going to make our lives better. So the question is, how do we actually implement that? How is the customer going to use that piece of silicon? That's the first question, and that's really a software question. So we started with that. There is a ton of existing hardware that already exists, and it works very well. So we started with answering, can we replicate a software that does not require you to completely change your infrastructure, but works very easily with existing infrastructure, and then go ahead and design or kind of co-design the hardware from there. Then, software is the elephant in the room that not people talk about. You kind of start thinking hardware first, but we started oppositely. This is starting from a software perspective and then getting to the hardware.
Did you interface with any of the big Japanese kind of IT companies, electronics firms?
Yeah, it's a good question. So in a manner, deliberately we didn't, but because we started from software, and there is a huge amount of challenges today, if you're trying to deploy a problem like an AI solution at the edge on the physical world, it's a very fragmented market. So one of the key players that we have been working with is a company called Renaissance Electronics. So they kind of reached out to us and kind of wanted to leverage our compiler technology, the software. Well, that could enable their hardware systems to be a lot more efficient and work very well. So that was a very interesting light bulb moment for us, that it's, while we are trying to build silicon that is a lot more efficient and kind of power efficient, we can also take that software and make it work across the broader ecosystem. Similarly, we also worked with SoftBank as another company. Today in this session, we didn't talk a lot about the impact of AI on overall wireless communication infrastructure, but that's going to happen. The promise of 5G hasn't really delivered, and that's really because AI has been scaling a lot more faster. So what we'll see in the next, I would say, 2 to 5 years is post-5G world getting a lot more accelerated as a byproduct of the growth of AI, and we kind of started that journey early on, partnering with many telecom companies ourselves.
Thank you. So I think that for the whole question of whether AI or how AI can become creative, Akari-san, let me ask you.
Yeah, that's a pretty good question. I think the interesting thing is that we have seen like a lot of impressive capabilities with language models, but when it comes to the context of creativity, we started seeing that like those models can generate really high quality content, but when we take a look at what they generate, many of those contents are actually copying existing contents, like existing novel, existing animations, existing research ideas, and then kind of slightly modify or combine those ideas. And I think there are like two things. The first one is that I was wondering if the current way we train the models and no encouraging model to generate completely new ideas or creative something much more creative, because for example, when it comes to hallucination, we are trying to reduce hallucination, but when we want to generate something completely new, then maybe we needed to encourage the model to hallucinate more, but it's a different context. But we haven't explored how we can increase the models to generate completely new content in our previous mainstream training way. And another thing is that when it comes to creativity, there's a huge right now there's a tension between copyright and also the model's final output and training. And there are a bunch of lawsuits going on around AI language model copyright, because many of the models are trained on copyright protected content, and it's still a bit unclear whether we can use those data for training, or the model can generate content that is similar to those copyright protected content. So there are both interesting questions about technical development as well legal or more societal mechanism design aspect.
can I add 30 seconds of comment very quickly? I think it's a brilliant question, and it's kind of a catch-22. So if you think about creativity, it by definition means that you cannot follow established norms. You're doing something different. And I think that's really where the problem lies. We need to put guardrails into AI today in order to be able to kind of risk mitigate it. The moment you add guardrails on data as well as what it behaves, you're kind of hampering its creativity. And that's something, I don't have an answer towards it, and maybe Shane may have, and that's something that one has to think about. How do you balance the guardrails, the risk mitigation aspect of AI, vis-a-vis our desire for it to be creative?
Yeah, I'm going to call that a question and throw it to Shane. Remembering that you were talking about your 3-year-old who is very creative and most of it's
Extremely creative.
hallucination.
Yeah, so I agree with basically the other kind of comments that essentially like I think there are two kind of main things that's really kind of like one is basically this sort of like guardrail, like make it tune in such a holistic list and kind of cram in tune in such that they sort of kind of give like like not too crazy kind of answer, make it more predictable so you can, and also just like on the benchmark, like what we kind of find is that if you increase diversity of the generation, you naturally kind of make some of the like answering the math questions, this kind of coding questions less reliable. So you definitely don't want AI to be too creative when they're acting as your coding assistant. So once that, a lot of tuning is kind of designed for it. But the other is also what I mentioned before that essentially right now you're increasing the model size and then training data scale to reduce hallucination. And in a way, like the current sort of more like supervised kind of pre-training kind of regime of training is basically kind of treating everything as sort of the same in terms of the outputs. But one way is maybe you can, but humans are different, right? Our goal is not to just copy, for example, this painting, like, pixel by pixel. Our kind of goal is to learn something from this painting such that I can create the new art that can be recognized by society. So if you kind of start moving from sort of pre-training, sort of copy kind of regime more to like reinforcement learning that you're doing this generation for like a purpose, then I can kind of imagine that AI can be kind of more creative as well.
Okay,
so, and both of them essentially the kind of solution to adjust the reinforcement learning.
Interesting idea. Let's do another round of questions. 1, 2, 3. You're first. Yep, you. And then back in the back, and then 3.
Thank you. My name is Kelvin. I'm the Program Director of English MBA program at GLOBIS. My question is, what is the next frontier when it comes to AI technology? Like, for example, Fei Li from Stanford, she started building the world model. She thinks that LLM is not enough. We need AI to understand spatial intelligence. So I just want to know from your expertise, what is going to be the next frontier when it comes to AI model, and what would Japan's position be when it comes to this new AI technology?
Okay, great. Back in the back.
Yeah, Jorge Calvo, Deputy Dean of GLOBIS. A model can win all the benchmarks and still failing in real life. How can we measure real performance?
Okay, great. And then the third question.
Hello, my name is Dimitri. I'm a student here at GLOBIS. My question is, well, first, I have no doubt in my mind that AI is going to continue to develop at a very high speed. My question is, where is the peak of where AI stops being beneficial for humanity and starts harming humanity? Like, for example, it could generate movies, it could just do everything or creativity could be lost, or even governments could use it as a weapon. So where do you think is the peak of where it will be beneficial and turn into dangerous?
Okay, thanks. So for the next frontier, Sakya, I want you to take that one.
Sure. I think it's a tough question in general and difficult to choose just one, but I would say two main areas. One you already mentioned in a manner. So today, a lot of the things that AI can do is restricted to the data that's available, and it has very limited memory. So I think the next frontier is going to be really on the model side, on persistent memory, world model, so to speak. Humans are very good at planning. So that whole planning aspect is not really, and planning and reasoning go hand in hand together. We are still not there with AI today. And I think that's going to be the next frontier. Being able to predict what's going to happen in the future and be able to plan towards it in various manners. That's a critical component of model development. The second, on the hardware side, I think we'll see a lot more development towards efficiency. As I mentioned, sustainable autonomy. Today, the world is kind of dictated by one form of hardware. I was on another panel and I recently mentioned there's a really nice paper. I keep plugging this paper. She doesn't pay me anything. But there is a paper from one of Shane's colleagues at Google called Sarah Hooker. She wrote a paper called the AI Hardware Lottery. And that's what really is. At any given point in time, the algorithms and the models that succeed are really the hardware that's available at that given point in time. So what we'll see beyond the model side, we'll see hardware coming up. That really dictates in the next 10 years which models beyond today's transformers is going to be the key towards enabling efficient autonomy in the future.
So then we have the whole measurement problem. Shane, I'm going to throw that one to you. What is the real performance metrics that we should be looking at in terms of measuring the quality of AI, its ability to do things?
So these days, kind of a lot of frontier labs still kind of competing on this kind of public benchmark. But what's kind of really kind of happening behind the back is that we're just optimizing for like a lot of really like end-to-end kind of use cases. So when like a coding tool kind of use our model, how does it kind of work end-to-end, and what are kind of feedback from there? When the business kind of use the model, then what are the implications from there? So to me, the real kind of feedback basically come from everywhere. So the nice thing about reinforcement kind of way of thinking is really like it's kind of end-to-end. The reward function can be anything. So the essentially like what we kind of see is that the model, so the model developers like Google, OpenAI, and Anthropic are kind of getting closer and closer to both B2C endpoint and also B2B. So many different places are having like locking like multi-year collaboration with different businesses. Many are kind of going, for example, integrating shopping, integrating sort of more like kind of full search kind of capability to it to kind of make end-to-end products. So the kind of key is really like you cannot be satisfied with just model performance. You have to make a model into a real product, and then ensure that you can have like metrics upstream from the real product. That's kind of what I think that's like the advantage like a lot of frontiers to have, which are kind of less discussed because like on Twitter, many people just can't talk about the benchmarks, but really like what we're spending a lot of our time is to ensure that end-to-end product is improving day by day.
Okay. So the last question is really hard because all of our panelists have kind of, invested their careers in the future of AI. But Akari-san, I have to ask you, do you see a peak and social backlash, or what will happen in terms of people's attitudes toward AI going forward?
I think it's pretty difficult question. I think AI has been, especially in the past few years, as those AI models are getting more and more powerful, we have already started seeing like a lot of potential issues or like real world problem with those systems. For example, like there are multiple cases where like chatbot basically like kind of encourage like young people to like commit suicide, or like those models, some research shows that like those models have capability to generate completely new like materials or like even like virus that can like actually like spread like new pandemic. And I think the important thing is that all of like key players like industry, like leading companies or like academic research institute must have like way to like measure and like audit and interact to avoid those potential risks. For example, like before like deploying new models, all of the companies needed to do like really careful like assessment on like what the potential risk of those models, like how, and like introduce like red teaming or like additional like safety network so that like those models will not generate like, any harmful content. And the problem is already happening. And I think that more and more players needed to pay more attention to like how we can what kind of risks we have and like how capable those models are, and like how we can do like pre-deployment, post-deployment assessment and audit and like red teaming to avoid those potential risks as much as we can.
Okay, so last quick question, lightning question from me to close the round. Are you worried that the AI community is going to become too isolated from the people who are not expert in AI? Is this something that we can avoid in some way? Shane, you first.
Yeah, I really kind of, I said the reason I kind of spend time kind of coming to a place like here is that I really kind of feel since like 2-3 years ago that AI can like doesn't really have a kind of bound in terms of like how much it can really kind of change and develop. And then I think there has to be kind of much more conversation between the So like non-AI developers and the AI developers. And in the
Okay.
end, as we kind of discuss, the technology is really kind of up to the people if it can really benefit together. So I think all of us, including, we including the panel, but also people in the
Yeah.
audience, we should kind of try to understand each other. Yeah.
Okay, great. Akari-san, to you.
Yeah, I think the understanding is quite important. Like for like non-AI people, like it is pretty important to understand what those models can do and what those models cannot do. And from like AI expert perspective, it's really important to understand what non-AI expert want those models to perform or like what their true needs. And based on that, we can develop like better benchmark or we can like train model in the way that are more useful for like real peoples.
Okay,
And I think the more conversation between those two would be quite helpful for both sides.
great. Thank you. Sakya, you have the last word.
Yeah, finally, I would say that there's got to be a lot more conversations around moving from speculation and the hype to what can really be achieved in terms of possibilities. And I think that's all of us in a manner are doing that. And I think we'll see more of that. And I think the government has a lot of big role to play in that as well, in order to enable those conversations to happen sooner rather than later.
Thanks, and thanks to everyone for your interest.